I'm Anil Kumar sharing with you some questions based on radicals. We will see how to simplify these expressions and also how to rationalize when required. So the first four examples are to work with surds or square roots. And the last two questions here, E and F, you need to rationalize and then simplify. So for E and F, we'll do rationalization. Okay. You can always pause the video, answer these questions, and then look into my suggestions. They will cover a major part of your introduction to quadratic equations, where you should know how to work with square roots or surds. So let's begin with the very first example. We need to simplify, rather in this case you can also say evaluate, right, sometimes. Okay, so we'll simplify 5 square root of 192. Now how do we get factors of 192? One way is we could actually form kind of a factor tree. So if I divide it by 2, since it's an even number, then we know 2 will go 9 times, then becomes 18, and 12, that means 96, right? So further we could divide this by 2, and then what do we get? We get 2 times 4 is 8, right? And 16 is 8 times. We get 48. Now 48, we could follow this process and go further, saying 2 times what? We get 2 times 24, and then 2 times 24 is 12, and then 2 times 6, and then 2 times 3. So we could kind of do prime factorization. This is a lengthy method. You get 1, 2, 3, 4, 5, 6 2's, right? You could actually pair up these 2's to find the square root. So this pairs up into 1, another pair, and then we have one more pair, right? So we get 6, 2 to the power of 6 kind of, times 3. So I could actually write 5 square root of 192 as equal to 5 times, there are 6 of these 2's, right, times 3. So we get 1, 2, I just wrote 3, 3, 4, 5, 6. Now, each combination, when you multiply within the square root, it is 4. And square root of 4 will be 2. So we could take half the number of 2's outside the radical sign. Correct? So that was the question given to us. Now that means we could do it like this. 5 times 2 from 1, then another 2, and then another 2, square root 3. Correct? So that becomes our solution. 8 times 5 is 40, and we get 40 square root 3 as our solution. Do you get the answer, right? So this is one way of solving such questions. So prime factorization of a number helps us to write the number in a factored form, from where we can pick up the combinations which repeats and then get the answer. Well, so this is a very effective way. It may look as if it takes long time, but it really doesn't. Now let's look into another question. Now again we have a very similar question. I'll follow this strategy to show you how effective it can be. We have to work with square root of 51, right? So let's find factors of 51 this time. 5 plus 1 is 6. So I could divide it by 3. Do you see that? And 3 times 1 and 21 means 17. So I could write 51 as 3 times 17. So we could begin with minus 3 square root 51 times 2 square root 3. Now 51 could be written as 3 times 17, right? Times 2 times square root 3. Now you have to multiply the outside numbers with the outside numbers. 3 times 2 is 6 with a negative sign. So we get minus 6 here, and inside numbers. So we get 3 times 17 times 3. Now since we have these two 3's, one of them can be taken outside. square root of 9 is 3, right? So we get square root of 9, which is 3. So we are taking this 3 outside. So we get minus 6 times 3 within square root. We have 17, and that gives you minus 18 square root 17 as our answer. Correct? So that is how you could simplify the given expression. As you can now see, prime factorization really helps to answer such questions. Correct? Now let's take the next one. Now I'll share with you another strategy here. We can do it faster once we understand the concept, right? So we'll begin with this question: 3 square root of 12 plus square root of 24 minus 2 square root of 36. Now clearly square root of 36 is 6, so I could write this as 2 times 6. Now what should I do with 24? So when we are looking at 24, we want to write factors, and we are looking for a factor which could be a perfect square, right? So we know 4 times 6, right? So 4 times 6 can work. 4 is a perfect square. That's the whole idea, right? So we could write 24 as square root of 4 times 6. Similarly, for 12, we could write 12 as product of 4 and 3. Why did we choose 4 and 3, not 2 and 6? Since 4 is a perfect square. So the idea here is to have a perfect square. So that is a good strategy. So if you follow that strategy, you can do this even faster than what we did last time. Now square root of 4 is 2. So it becomes 3 times 2 square root of 3. And here again we get 2 square root of 6. And then here we have minus 12. Now we have 6 square root of 3 plus 2 square root of 6 minus 12. Now nothing is common and it cannot be simplified further. So we just stop at this stage. You get an idea, right? So that is the final simplified form of the given expression. So I hope the steps are absolutely clear. So I'd like you to follow this strategy and then answer the next one. Here is the next question for you. In this particular case, we'll apply the distributive property to open the brackets and then simplify. So we have 3 square root 2 times 6 square root 6 minus square root 10 minus 5 times square root of 12. So when you apply distributive property, you have to multiply both the inside terms with the term outside. So we get 3 times square root 2 times 6 times square root 6 minus 3 times square root 2 times square root of 10, and here we have minus 5 square root of 12. So 3 times 6 is 18, and within square root we have 2 times 6 as 12. Now in this case we have minus 3, and within square root 2 times 10 is 20. And finally we have 5 times square root of 12. Well, I could combine these two terms. I could do that and then simplify for 12, since we have a common denominator which is kind of 12, right? So we could do that. So we could do 18 minus 5. So let me rewrite this. 18 minus 5. So I'm combining these two terms and writing them as 1. So 18 minus 5 is 13. So we get 13 square root of 12. And we are left with minus 3 square root of 20. Now let's work with square root 12 and 20. 12 could be written as 4 times 3. Correct? And this is not 4.3. This decimal here is times. It's not a decimal, right? So it is 3 times 4 times 5. I chose 4 since 4 is a perfect square and it could be written as 2 square, and therefore I could now write this as 13 times 2 and within square root 3 minus 3 times 2 within square root 5. So this is a better way of writing, because that decimal type of a multiplication sign sometimes confuses. But anyway, this is standard way of writing also. Now 13 times 2 is 26, so we could write this as 26 square root of 3 minus 3 times 2 is 6, 6 square root of 5. So that becomes the simplified form of the given expression. Now let's look into rationalization. We need to simplify square root of 3 over square root of 5 minus 2. Now, to rationalize, we have to multiply and divide by its conjugate, correct? Conjugate is an expression which will, conjugate of this will do rationalization. Let me explain more. Of denominator. That means multiply and divide by the conjugate of the denominator. In this case, denominator is square root 5 minus 2, so the conjugate will be square root 5 plus 2. So the idea is that when you multiply, so let me give you an expression, a plus b times a minus b. So when you do a plus b times a minus b, you get square, difference of squares, right? A square minus b square. So that removes the square root sign and we could now simplify. So these are the steps. So rationalize a denominator really means first step is multiply and divide by the conjugate of the denominator. So what do we get here? So we could write this expression as square root of 3 over square root of 5 minus square root of 2 times square root of 5 plus square root of 2 over square root of 5 plus square root of 2. Now it is as good as 1. Multiplying anything by 1 really doesn't change your equation or expression, correct? So that's fair enough. Now you could actually see that the denominator will be square root of 5 square minus square root of 2 square, which is 5 minus 2. So I could now write this expression as square root of 3 times square root of 5 plus square root of 2, and the denominator will be only 5 minus 2, which is 3. So let's expand the numerator. So we get square root of 15, 3 times 5, plus square root of 6, 3 times 2, divided by 5 minus 2, which is 3. Do you see that part? So that is how I could actually simplify the expression and write without a radical sign in the denominator. So that is a simplified version of what we had. Now let's take one more example, and that is the last one on this series. So now we need to simplify 5 square root 3 minus 3 square root 5 divided by square root 5 minus 3. Now again, rationalize denominator to simplify, right? That is to say, we have to multiply and divide by the conjugate of denominator, which is square root 5 plus square root 3. So let's do this step. So we have 5 square root 3 minus 3 square root 5 divided by square root of 5 minus square root of 3. We'll multiply and divide by square root of 5 plus square root 3 divided by square root of 5 plus square root 3. So that is the first step for rationalization. So that will give you, in the numerator, you have to apply the distributive property. So square root 5 square root 3 will be multiplied with both these terms. So you get 5 square root 3 times square root of 5 plus square root of 3 minus 3 square root of 5 times square root of 5 plus square root of 3, correct? And in the denominator, you get difference of the two. So we get 5 minus 3. You get an idea, right? Now, when you open the bracket, 5 times square root of 15, you will get from the first product. Then you get plus 5 times square root of 9. Now, square root of 9 is just 3. So we'll straight away write 3, right? So square root 3 times square root 3 is 3. Minus. Here we get 3 times 5 plus 3 times square root of 3. So I hope that is absolutely clear. Divided by Now, 5 square root 15, we have 5 square root 3 and 3 square root 3. That could be simplified. So we could actually combine these two expressions and write a simplified version. The others will remain as such. So we have 5 square root 15, and when you combine these, 5 plus 3 is 8, we get plus 8 square root 3, and 5 times 3 is 15, so which is minus 15 divided by 2. So that becomes the final simplified version of the given expression. So I hope that helps. Feel free to write comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.